Alright, this is part E, and again we have this x5t. I want to build this x5t based on xt. Similar to the previous parts, I try to partition this x5t into smaller parts, and for each part I try to find the expression based on xt, and then at the end I add them up all together to find x5t. Right. So here I can partition this x5t into three parts. The first part is here. And the second part is here. Let me use different color for this part. And you see that this triangle is actually the time inverted of the blue one. And at the end, we have this rectangular here. Alright, well, this rectangular is pretty much similar to the signal x2t we draw in part B. Okay, so in that case we had a signal, and it was pretty similar to this one, but its width was from 1 to -1 to 1, so it was like something like this. Okay, this is x2t from part B. And now this yellow one, this part here, is actually the compressed version of that x2t. And we know that if you want to compress a signal, we should replace t by alpha t. But what that should alpha t be? If we want to compress, if we want to expand, I should do this. Well, actually we want point -1 to go to point -0.5, okay? And we want this point 1 here move to point 0.5. We want 1 to go to 0.5. Alright, so considering this, we can calculate alpha by dividing 1, where it is, by 0.5, which is 1 over 2, and that says alpha equal to 2. So if I want to compress this signal, then I should set alpha equal to 2. That means this yellow part, I would say this equals x2t, but times alpha is 2, so I can say x of 2 times t. Alright, and we know that the expression for x2t was let me pause the video because I cannot remember that, but I think it was like x of t plus 1 plus x of minus t plus 1, then x of t plus x of minus t. So let me just double check. Oh yeah, that's correct then. So that means this yellow part can be written like this: x of 2t. I replace all these t by 2t, okay, by the scaled version. X of 2t plus 1 plus x of minus 2t plus 1 plus x of 2 times t plus x of minus 2 times t. So we've done the we find the expression for this yellow part. So for the blue part, for this one, you see this is the actually the shifted version of this xt, because the width is from minus 0.5 to minus 1.5. So the width is 1, similar to here, and the height is 1, similar to here. So this is actually just the shifted signal, shifted xt in time, and I would say this is shifted by, well, this point 0 is moved to minus 1.5, so I can say this has been shifted by 1.5. And the green signal, the green part in the right, this one, is just the time inverted version of this signal. If I flip this signal across this vertical axis, then we would have the green part. So I can say the green part is minus t, because if I want to invert a signal, it's just enough to replace t by minus t plus 1.5. Okay, so we got all parts we need. So I can write x5t based on these three parts. So x5t equals, so let's see, this is part 1, this is part 2, and this is part 3. So x5t equals x2 of 2t for part 1 plus x of t plus 1.5 plus x of minus t plus 1.5, and this is for part 3. But we need to write everything based on x3, so I replace this one by its expressions based on xt. So x5t equals x of 2 times t plus 1 plus x of minus 2t plus 1 plus x of 2 times t plus x of minus 2 times t plus this part and this part, x of t plus 1.5 plus x of t minus t plus 1.5, and this is the expression for x5t.